Right, in this particular video I'm going to derive for you a new formula that you need to be familiar with and be able to use. What I've drawn here is a sector of a circle with theta marked in, the angle theta, and we'll be talking about that in terms of radians. I've drawn a full circle and a full circle angle marked in. Well, obviously it's 360 degrees, but if you look at the previous video, 360 degrees in radians is a 2 pi degree angle at the centre. Okay, now what I'm going to do is I'm going to compare the size of that angle to that angle. So I'm going to do that by setting up a fraction, which is a ratio. Theta in rads compared to the 2 pi rads for the full circle. So I'm comparing the size of the angle in each case. Now that ratio, whatever that value turns out to be for any particular specific questions, will be the same as if you compared their areas. So the areas will have the same ratio as the size of the angle. So obviously if you double the size of the angle, you'll double the area. If you treble the sector's angle, you'll treble the sector's area. That's how it works. So the area of this, well, that's what I'm trying to derive. I don't know what the formula for the area of this sector is, so I'll just call that A. That's the area of the sector. Compared to, now we do know what the area of a full circle is, because we've done that in the lower school. It's got a formula pi r squared. So let me say this again. If you say the angle in rads of the sector compared to the angle in rads of the full circle are compared, the answer you get will be the same as comparing the area of the sector compared to the area of the full circle. Those ratios, either side or the equal sign, will be the same. So what does this mean? It means that with a bit of algebra manipulation, if I take the right hand side and multiply both sides by pi r squared, you just get A on the right, and you're going to get pi r squared theta on the top over 2 pi on the bottom on the left hand side. This is a fraction. Fractions can cancel. You can get the pi's cancelling top and bottom. And you're left with simply r squared theta over 2, which we normally would see in a textbook written as a half r squared theta equals A. And what that is telling you is that the area of any given sector A is the same as a half times the radius squared times theta in radians. So all you need to know is what the radius of the sector is and what the angle in radians of the sector is, and you can work out what the area of the sector is. And there you go. There is a formula which you need to learn off by heart. It would be good to know where it's come from, just in case you're asked. I haven't seen it asked for many years, so it's doubtful they'll ask you for this bit of proof work here. But you definitely need to learn that and know how to apply it in calculations. And I would say to you, we'd normally write it the other way around, a half r squared theta like that. And if you then put it together with the other formula that we looked at in the previous video, S equals r theta, which is the arc length is radius times theta in rads. Those two formulae now are what you need to learn and be able to apply in various calculations of one form or another.